Yeah, this is Cheryl Thomason, and this is teaching computer science. And I am doing the part methodologies where you present an instructional lesson on several topics. And the topic that I chose was computational thinking. And I'm a science teacher, so on many occasions have taught the concept of density. So I've prepared this worksheet or the spreadsheet on Excel to show how you can, for the objectives, find the density of objects by measuring them with analog equipment, of course, and then also by water displacement. Also want to show them how to create a spreadsheet for recording the data, but then also to write algorithms to perform all the calculations. And then to determine, they have to determine the correct number of sig-dig, significant digits, and then they have to set their cells or their columns to reflect those number of sig-digs. So then they would have to do that at the end, and then they want to calculate the percent difference between the two methods. I have shown here on the screen that maybe you would pick this set of objects to find the density. Obviously, you would probably know what these things are if you ordered them, because they typically send you what the density is, but I'm not so concerned with this right now for them to actually get the correct density as much as I want them to learn how to manage a spreadsheet and write algorithms so that the cells and so that the spreadsheet will do all the calculations for you. They would use a triple beam balance and, of course, a metric ruler. So I have gone ahead and set up the spreadsheet. That took me a little while to do that. And I have not put any algorithms or anything in here. But this is something like what it would look like maybe. And you can add borders and that sort of thing. But anyway, so over here, first thing you have to do is you have to know the mass. And I've put my units up here at the top so that you don't have to record them, so that the math, the numbers will work in these spreadsheets. But I don't have any data here. I'm just making all of this up. So I will, in a triple beam balance, measures two places to the right of the decimal. So I'm just going to make up some numbers. Let's say 12.56. The block might be 9.83. The aluminum cylinder might be, I don't know, let's say that it is 11.25. The block is a little bit bigger, I think, is 17.03. And the one with the hole in it, up here, then they'd have to do a little extra calculation to, which I didn't put that on here, but they could. 16 point, that might be another teaching moment for them. All right, so then, of course, you would try to determine the volume of these objects. So these would be the pi r squared times the height. Of course, these are length times width times the third dimension depth. And then here you'd have to find the area or the volume of this hole and then subtract it from the volume of the entire object. I didn't actually do that one, so I just wanted to show some things. So let's say we wanted to do the height of the cylinder. And let's just say that it is, let's say that it is about 7.25 centimeters. The diameter, let's say that's 1.30. There would be no length in this case and no depth. But in order to find the volume, since it's a cylinder, then you're going to have to write an algorithm that's going to go in this column. That is pi r squared times the height. So you would just start out by saying equals, and you would click on this height column, and then you would say times, and then I don't know if pi is in here, but let me see if it is. It is pi, and if you see here, if you pick the program's pi, then they're giving you 15 digits. Of course, we don't need that many digits because we only have 3 over here. And then they put another digit there. So we only have 3 digits, but that's okay because this is a constant and you want to use as many digits as possible. And so then we'll continue with that times. This is the diameter, so we want to divide that by 2. So let's put a parentheses there, and let's put diameter, and then we're going to say divided by 2 times, and then we want to square that, and let's see if this works. I'm not sure how if this works. I'm not sure if that's going to work, but we'll see. And that should, let's see what happens. Okay, so obviously that didn't work. So let me see. Let me let's see. There's got to be a way to square. So let's put it right here, and let's see SQ. So because I'm just going to do it again. That'll do it, which is probably not the best way to do it, but at least that's what I'm going to do because it'll make it faster. And let's see what happens. Okay. Times pi. Well, let me see. Okay, so let me just try this. See if that works. Okay, so that's not what it is. So, all right, so we're going to go back over here. This must be where the problem is. And we're going to say 3.16. And let's get that to work. Okay, so that's going to work. So I'm going to go back up here. All right, so then times open parentheses, the diameter, divided by 2, close parentheses, and I think this is going to work. Square. So there it is, and you see that it's got, and let me go over here and add another digit just so there you go. And so now you see it's got 1, 2, 3, 4, 5, 6, 7 digits, but I can only have 3. So I go to that place right there, and I can decrease the number of significant digits by just decreasing it here on the screen. So I have 3 over here, 3 over here, I have 3 right here. Now, no matter what you put in here from now on, if you're using the diameter one, then you're going to have that as, so this same equation here would go into that one. So you can just copy that, and you can just put it right here and paste it, and I'm pasting the formula. And then over here, I would go measure the height, and let's say it's the same thing, 7.25, because they probably are. They're trying to make those cylinders about the same. And you can see that based on this, let's see what this was. Let's see how different it was. Okay, so it's not much, it's no different. So let's see. Oh, no, that's right. The volume would not be different. So the volume is the same, and that's what we want. So once again, we decrease this to 3 sig digs. And then, of course, when you do the other algorithm, the height, which might be, and again, I don't know, I'm just making it up, might be 6.02. The diameter we don't have, the length would be 7.15, and the depth would be, let's say 0.97. And so now I want to, and I'm running out of time, so I'm going to stop here pretty quickly. But anyway, you can see that using all of these algorithms, so if I write the algorithm for this, it is equals height times length times